Good afternoon, dear ladies and gentlemen. Welcome to my presentation, Sustainable Interdisciplinary Planning of a Police Department in Germany. Here you can see we completed this project in record time of 2.5 years, planning and construction, which took place parallelly with the help of several BIM solutions, and around 430 police officers are working here. Let me get into some key project information. We won the first place in a Europe-wide tender to realize this project. It was the first BIM pilot project for all the stakeholders. The first police department in Germany, hence we set a benchmark, and it was a best case scenario for open BIM. So like I said, it was a record time in planning and construction which took place in 2.5 years. It is a DGNB Gold certified building, which is sustainable in planning, construction, and also computer-aided facility management. So we're talking about sustainable certifications, something similar to LEED. A property area of 21,000 square meters and a gross floor area of around 17,000 square meters. So we provided this building with charging stations for electric vehicles as well as bicycle parking, a total investment volume of 66 million euros, and like I said, best BIM practice recognitions from company Hilti, Nemetschek, and also University of Stuttgart. We started with BIM 3 years ago. So how did we achieve all this success in a short time? We made a BIM steering committee in the company in order to implement BIM. So firstly, we got our employer information requirements right. And then we decided about the software solutions as well as the interface. And a BIM execution plan was developed. The tasks, competence, and responsibilities of the colleagues were redefined, because you see people were working for 30 years in this company in this conventional method, and I come, who is also 30 years old, and explain them how to do BIM. So we need to modify their roles. Then we set our BIM use cases, and it was defined and prioritized and assigned to a specific responsible department. We set milestones and linked these to a specific deadline so that they can be executed in the right time. And then we identified trainings and organized internal as well as external trainings, because a change means you need to be trained. So we were talking about around about 30 different companies, subcontractors who were working with us, and they had to be brought down in a specific ordner structure when they are supposed to do BIM. So then we talk about, okay, we have BIM management, overall coordination, BIM coordination, BIM parameter delivery, and the BIM users. And you can see in the BIM users were the one who profited from the building information modeling, or from the digital twin. You can see the police, Dresden Soma were there, and also DGNB, the sustainable auditors. So we created a workshop in the beginning and set BIM targets. Some wanted to do 2D plans, some wanted to have sustainable material catalog. It was too not defined in the beginning. So we had to bring them down specifically into architecture department, assign them to site engineer, site management, calculation, marketing, sales, as well as the BIM management. So you can see architecture were responsible for 2D plans, change management, building regulations, sustainable material catalog, but BIM were always there for the support and for the implementation. So talking about the open big BIM information, we oriented to BIM guidelines from ISO, DIN, VDI, and also Open BIM standards. And just to mention that we are also BIM champions for 2023 in the German chapter, because of this project in a short time that we could realize the BIM goals. In Germany, we have 9 planning phases. So in every planning phase, we had a specific project goal, which was interlinked and checked with model with the help of IFC standards, Solibri, BCF, BIM collaboration format, and also BIM Collab Zoom. We also oriented ourselves to DGNB Gold standards. So here you can see we developed a specific naming logic, which was there in each and every material of our building, for example, the door. And hence, we developed a set of modeling guidelines, which was supreme discipline for us. So we have a structural shell model coming from the structural consultants, an architecture model, and MEP. We had heating, cooling, and other aspects like sanitary and also electrical. So, like I said, 30 different companies, open BIM. So we had 26 software solutions. And we had to bring all these software under one map and hence the free choice of operating system led us to make this project as Open Big BIM. So we're talking about IFC interface. The data transfer was smooth and efficient. And to achieve the project goals, we had 21 BIM use cases and 5 open add-ons. So I brought some examples of some use cases. Maybe we can keep in contact and discuss later in detail the further ones. A uniform naming logic and modeling guidelines developed as per international Open BIM standards ensured high transparency and efficient data transfer in the project. So here are a picture of the 26 Open BIM outcomes, BIM use cases what we had. So we prioritized them into category 1, 2, and 3. Let's say one was let's say time scheduling. It was under the construction management department. Let's say priority 2 was tendering and contracting, was again to the calculation department. And let's say we're talking about 3, which is computer-aided facility management, and the facility management was responsible to develop this. So some add-ons were earthquake analysis. In Germany, there is no earthquake zone, but near the mining area in Cologne, we have to do an earthquake analysis, and that's why we had to do that. So let's come to the structural key outcomes. We had model-based structural calculations, as well as earthquake analysis, automated implementation of slit and openings with the help of Dynamo. Formwork drawings, structural drawings, and reinforcement drawings were made model-based. So you can see the positive outcomes were optimization of the structure, and also we had an earthquake-resistant structure. You can see in the bottom the workflow of Open BIM. I don't want to go in detail, but you can see the architecture came from Allplan and Trimble Nova from MEP, Dynamo for openings, and Revit and Tekla for structure. And this is how it went on for each and every BIM use case. So let's talk about MEP. We had detailed drawings for the MEP models, model-based calculation for heating, cooling, air supply, and lighting. And we also had the MEP models merged into one coordination model to help for geometric collision checks. The issues were published in BCF format, in BIM Collab interface, and directly also to the operating systems. So this gave us the opportunity and the positive outcome, collision-free planning and smooth workflows. With the help of company Hilti, we could optimize our MEP planning. You can see here our original plan from the for MEP guys were single console, mechanical, ventilation, electrical, sprinkler was separate. So we had to make it into multi-console so that we could save a lot of material and also save the installation time, because time is money, guys. We had earthquake-proof anchoring systems, and also the planning and acceptance of the fire insulation was significantly simplified with the help of IFC interface. Like I mentioned earlier, the slit and openings were completely model-based. We are talking about 30,000 openings, which came as voids from the MEP planners. With our own Dynamo script, we could implement them directly in the structural model, check it in Solibri, and then we could plan further ahead. So it was a transparent and efficient coordination between the planners, and the rationalization and quality improvement in cutout openings were achieved. So we're talking about automated workflows and also better plausibility checks. Coming to the class detection, here we could achieve in this use case coordinated planning with quality assurance, early detection of issues, and we also see cost reduction by avoiding construction delays. So the positive outcomes were we had around 7,800 collisions which were detected before, which did not land in the site as a surprise for us. And we're talking about 60,000 euros per day fines if we didn't deliver this project in time. And thank God we did it in time, because of such BIM use cases. 4D and 5D was also a part of it, scheduling and cost controlling. With this use case, we had efficient quantity takeoff, accurate cost estimation and cost calculation, model-based tendering and contracting, and also targeted as well as actual comparison of deadlines and costs. So this gives us the positive outcome. Costs and deadlines were all time under control with the help of 4D and 5D simulations. Sustainability is a very important aspect nowadays. ESG, taxonomy, certification. So what we did is we packed in almost 150 parameters in the model, which were used. Some of them were also sustainable parameters, which helped us in the documentation of the gold certification automatically, which generated from the model, and which was a simplified process. Here you can see a picture of just the insulation of the building. we have 30 different types of insulation, and they were we could use and help them with the parameters. And here you can see with Solibri, we also could do the calculation of the exact quantities. So we're talking about circular economy using DGNB Gold certified building materials. A cycle of future use is ensured as sustainable parameters were stored in the IFC model. Sustainable Circularity Passport was also developed. All building components were selected as per DGNB material catalog with the help of IFC interface. So hence giving us the positive outcome, reducing miscalculations, improved life cycle assessment, low carbon footprint, and also climate-friendly building in the end. Prefabrication, we are a construction company. We are building for 6 generations since 1878. So we're pretty good in prefabrication nowadays. So what I'm talking about is efficient work cycles, reduction of setup time, optimal utilization of the equipment, and just-in-time delivery of the construction materials. So you could see here our whole walls, columns, beams, even the floors were segmented, and we had a specific position number, so we could tag it with lean and say, when is it going to come for just-in-time delivery? Which means effective construction management through a model-based invoicing and cost management, quality management during execution, help detection of errors in advance, and we could make the right decisions. So the positive outcome here were Open BIM was instrumental in saving costs, resources, time, identification of increased costs were possible, and optimization potentials were increased. Lean management. So like I said, with the help of IFC interface, the construction progress was recorded, enabling us regular comparison between targeted and actual time schedules. Here you can see with the help of a model, we could directly document the pictures and 3 times a day the weather, and also the equipment which was used and also the number of people working there, and which helped us in digital documentation of weather, equipment, labor, and working hours. Lean management of the site with tact time planning in CDE for smooth workflow of the construction site. So this gave us a positive outcome, automated billing process, real-time tracking, and optimized site logistics. So visualization supported and simplified the interior design process. Virtual reality and augmented reality gave the police officers and the public officials a tour of the future building in advance. So we're talking about the positive outcomes. Material selection process was really simplified. And here you can see the internal minister, Minister of NFA, and also the senior police director. They could see beforehand how my building is going to look. And they were really excited about BIM later on the later stage. Defect management for a construction company is a very important use case. It helps us to document the problems on the site directly in a model with the IFC interface. And here you can see in the top, there was a picture which came from a construction site engineer saying, hey, you're missing insulation for the fire. And they give it a ticket number, 225, and then it's completed. And there you can see a picture which is already completed. So we had around 50,200 tickets which were there, and we could complete everything in time. So 3-dimensional documentation of defects, issues assigned directly to subcontractors through ticketing system, and giving us the positive outcome, smooth transfer to the warranty department. Facility management is also a very important aspect. Like I said, 150 parameters with our own Dynamo script were put inside the model. And because of this, we have a LOD 500 model, level of detail. And because of that, we could have our own cleaning concept simulation, or even fire drill simulation, or other simulations like evacuation potential or something, which they can do in a later stage. So hence, guys, in the conclusion, I could say, despite Corona pandemic, because we started 3 years ago, and despite supply chain issues, despite the war which is happening there, which affected the prices for us in Germany, all our deadlines and costs were under control. And thanks to higher data quality and minimal loss of information, we could convince the public sector the benefits of Open BIM. So 2 years ago, like I said, BIM was new territory for us, but now we are proud of our progress because this shows with BIM we have the right way. So thank you very much, and have a nice day today in the conference.